In this video we're completing example 3. We're learning how to solve quadratic equations by using the quadratic formula, which you can see over here on the top right. Now we've actually got 4 questions we're going to cover. We've got questions A and B here. On the next slide we have questions C and D. So why is it that we need to use the quadratic formula? In a previous video we learned how to solve quadratic equations by factorising them first. Well, sometimes you get into situations where the quadratic expression cannot be factorised, or maybe it's too difficult to factorise, in which case it's better to use the quadratic formula. You'll notice that the quadratic formula is used for calculating x, which is great for question B because we're trying to figure out what x is. But for question A, we're actually trying to find k. What do we do in that situation? Well, it's quite simple. You just cross out the x and make it k. You'll notice that we have a few pronumerals here. We've got a b, an a, and a c. Now, what do these pronumerals stand for? Whenever you have a quadratic expression like the one we can see here, it's usually broken into 3 terms. The first term has a pronumeral to the power of 2. The second term has just the pronumeral, and the third term is constant. It has no pronumeral. The a represents the number next to the k squared here. The b represents the number next to the single pronumeral k, and the c represents the constant term, which is -1. So I'm going to write down that a equals 2, b equals -3, remembering that we need to look to the left of the number to see if it's negative or positive, and the c is represented by -1. All we need to do now to find k is write the formula down and replace the pronumerals with the correct number. So I'm just going to write this formula down. Now b is -3, so if I replace b with -3, notice it already has a negative there, so if I go -3, it actually becomes a positive, so that's going to become just 3. Then I have the plus minus sign. I then have b squared. Now b is -3, so I'm going to substitute -3 in place of the b. It then tells me to subtract 4 and multiply that by a and then c. Now a is 2 and c is -1, so I'm going to multiply that by 2 and -1. I need to square root all of this. And then I've got a fraction, and at the bottom I've got 2a, or 2 times a. Now a is 2, so I'm going to write down 2 times 2. So all I've done is just substituted values into my formula. The next thing I'd like to do is work out everything under the square root sign. So I'm going to go equals 3 plus or minus the square root. What do I get when I square -3? Well, -3 times -3 makes +9. So I'm going to write down 9 here. I've also got -4 times 2, that makes -8. And -8 times -1 makes +8. So we've got 9 plus 8, like so. And then looking at our denominator, 2 times 2 is 4. So we'll write that down. Let's go one extra step for now. 3 plus or minus the square root. And 9 plus 8 is 17. So we go 17 all over 4. Now, why is it that I have a plus and a minus sign? Well, the reason for that is we need to have 2 solutions. Most of the time when you're solving quadratic equations, you're going to have 2 solutions. So one of the solutions is that we do 3 plus root 17 over 4. Notice that I'm ignoring the minus sign and I'm just using the plus. The other solution is that k is 3 minus root 17 over 4. So the reason we have this plus and minus is to represent our two solutions, one where we're plussing and one where we're minusing. Now these are called exact solutions. You'll notice that we are asked to express our solutions correct to 2 decimal places and as an exact solution. So we've represented them as exact solutions. We now need to represent them correct to 2 decimal places. How do we do that? Well, we bring up our calculator. Let's look at the first one. 3 plus root 17. 3 plus root 17. Now we need to press equals before we divide it by 4. Divide 4 will give us, correct to 2 decimal places, 1.78. So that's one of our solutions here. K is 1.78, correct to 2 decimal places. What about our second solution? This time we're going to subtract the root 17. 3 minus root 17. We need to press equals first before dividing it by 4. Divide 4 will give us negative 0.28. So that's our second solution. K could also be negative 0.28. I've just noticed I probably should have written or here, because my solution is either 3 plus root 17 over 4 or it's 3 minus root 17 over 4. So I've got 2 solutions that are exact solutions, and I have another 2 solutions that have been rounded to 2 decimal places. Why do we call these solutions exact solutions as opposed to the other solutions where we've rounded them to 2 decimal places? Well, if you think about it, when you round to 2 decimal places, that's not an exact solution. It's been rounded. Whereas the solutions above have not been rounded, they are exact. Now you've probably noticed that I don't have enough room now for question B, so I'm going to start with a blank slate. Now for this to work, I need to have a quadratic expression on the left hand side, and it needs to equal 0 on the right hand side. So I need to do a little bit of rearranging first. I'll start by adding 6x on both sides, cancelling my minus 6x here. I now have x squared plus 6x on the left. So I need lots of space. I'll start way on the left hand side here. X squared plus 6x. I also have negative 3 on the right hand side. So this will equal negative 3. Now I want it to equal 0, so I'm going to add 3 on both sides like so. And then I have x squared plus 6x plus 3 equals 0. Now the order of this is very important. You really want your pronumeral squared at the beginning, you want your single pronumeral in the middle, and you want your constant term on the far right, which is what we have here. The reason we need that is a is the number in front of the x squared, b is our 6, and c is our 3. So we really want it in that order where we get our a, then b, then c. Now if b is 6 and c is 3, what does a equal? Well, you might remember when there's no number there, technically it's a 1. So a must equal 1. So the first thing I want to do is copy the formula down. X equals minus b plus or minus the square root of b squared minus 4ac. All of this is over 2a. And now I'm going to substitute. I'm going to substitute these values into this formula. Now b is 6. So I'm going to replace my b with 6. It becomes negative 6. The reason it's negative is it actually starts with a negative sign there. Then we have the square root sign. B is 6, so I'm going to replace the b with a 6. I get 6 squared minus 4. And I'm timesing 4 by a and c. A is 1 and c is 3. So we times 4 by 1 and 3, and extend the square root sign. All of this over 2a. Now a is 1, so it's going to be 2 times 1 for the denominator. I'll start by simplifying everything under the radical. A square root sign is also known as a radical. What's that going to give me? Negative 6 plus or minus square root. You know, it doesn't hurt to just bring up a calculator and do this. So that's what I'm going to do. I'm going to do it all in one go. 6 squared minus 4. So minus 4 times 1 and times 3. That gives me 24. So that just saved me a little bit of time. 24 on top. And 2 times 1 is 2. Now, remembering that we're looking for two solutions, and that comes from this plus and minus sign. So we're going to have one solution, and we'll write that x equals this. X either equals negative 6 plus the square root of 24 over 2, or x equals negative 6 minus the square root of 24 over 2. And in case you've forgotten, the reason we do this is the plus minus sign means you've got to do one solution where you plus and one solution where you minus. These are called exact solutions. So we need to express our solutions as exact solutions, which we've just done, and we also need to do it correct to 2 decimal places. So we bring up our calculator for this. The first one we had was negative 6 plus root 24. So negative 6 plus root 24. We need to press the equal sign before we divide it by 2, giving us negative 0.55. So x will either equal negative 0.55 or x will equal, bringing up our calculator again, we've got negative 6 minus root 24 this time. We need to press the equal sign before we divide it by 2. Divide 2, we get negative 5.45 if we round up. Negative 5.45. So we've got our two solutions here. We've got our two exact solutions, and we've got our two solutions correct to 2 decimal places. All right, let's now move on to question C. You'll notice at the moment it doesn't look like a quadratic, but as I've mentioned many times, as soon as you see a fraction, let's do something to get rid of the fraction. We're going to times both terms by x. That's going to cancel the x below, leaving us with 8x minus 16 on the right hand side, and x times x will give us x squared. Now it's starting to look like a quadratic equation. We need to move everything to the left, so we've got 0 on the right. We need to subtract the 8x on both sides. This will cancel 8x, giving us x squared minus 8x on the left and negative 16 on the right. We will now add 16 on both sides, cancelling out the negative 16. We now have x squared minus 8x plus 16 equals 0. So what's the value of a, b, and c here? A is the number to the left of the x squared, so a is going to be 1. B is the number to the left of x, so b is negative 8. And c is going to be 16. C is the constant term. So I'm going to copy my formula down. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now I need to substitute these values into my formula. We'll start with b, which is negative 8, If I replace the b with -8, you'll notice there's already a negative there. That will create a double negative, and a double negative is a positive. So we'll just write this down as 8, meaning positive 8. Then our plus minus. Next we have to take b and square it. Now b's -8. We're going to go -8 squared. Next we have -4. So we'll write that down, -4, and we're multiplying it by a and c. A being 1 and c being 16. So times 1 times 16. Let's finish off the line for our radical here. And for our denominator, we have 2a. Now a is 1, so it's just 2 times 1, which I could have just written as 2 if I wanted. Alright, what's the next step? Well, let's work out everything here under the radical or the square root sign. So we'll bring up our calculator. We've got -8 squared. So -8 squared minus 4 times 1 and then times 16. And we get 0. That's quite nice, isn't it? So we've got 8 plus or minus the square root of 0, and 2 times 1 is 2, so our denominator is 2. Now what's the square root of 0? Well, it's 0, so we've actually got 8 plus or minus 0 over 2. Now if I'm going to write down my two solutions, one of them is that x is 8 plus 0 over 2, and the other solution is that x is 8 minus 0 over 2. And you might have noticed that both of these solutions are the same. 8 plus 0 is 8, divide 2, which is 4. And 8 minus 0 is 8, divide 2, which is 4 as well. This is one of those situations where instead of two solutions, we get one solution. And this will always happen when the number under the square root sign is 0. Now we were supposed to express our solution correct to 2 decimal places and as an exact solution. Our solution is actually better than that. We've got a nice whole number 4. Now we need to move on to question D. I've run out of room again, so I need a blank slate. Now this looks really hard, and you might remember a tip I gave in an earlier video where I mentioned get rid of those fractions. Fractions are a pain to work with. And the best way to do that is to multiply. So we need to multiply by 3t and t minus 3 so that we can cancel all of these denominators. So we'll times by 3 by t and by t minus 3, which needs to go in brackets because I'm multiplying by the whole expression t minus 3. And I'm going to do that to every term. So I'm going to do it to this term. I also need to do it to the term 5 over t. So I'm going to times that by 3t and t minus 3. And finally, the 10 over 3 needs to also be multiplied by 3t and t minus 3. So we'll start with our first term here. If we multiply it by 3t and t minus 3, the t minus 3's will cancel, leaving us with t minus 7 times 3 and times t. So I need to leave my t minus 7 in brackets because I'm multiplying this whole expression by 3 and t. So I'm just going to write 3t at the beginning of the brackets. Next, when I look at 5 over t, the t's are going to cancel, and I'm multiplying 5 by 3 and t minus 3. Now 5 times 3 is 15, so we're going to write plus 15, and we still have the t minus 3, so I need to write that next to the 15 in brackets, t minus 3. We'll now focus on the 10 over 3. The 3's will cancel, like so. Now we're multiplying 10 by t and t minus 3. So 10 times t is 10t, and we have our t minus 3 in brackets. We've taken the first step and we got rid of all the fractions. Now I need to give myself some room here. I'm going to move this to the left. Another tip that I've given is to expand all the brackets, and we do that because we don't like brackets. They're a bit of a pain to work with, so we can get rid of them by expanding them. 3t times t is 3t squared. 3t times minus 7 will give us minus 21t. 15 times t is 15t plus 15t. 15 times minus 3 will give us minus 45. 10t times t will give us 10t squared. And 10t times minus 3 will give us minus 30t. So we have no fractions and no brackets. We want to move everything to the left-hand side so it equals 0. We'll start by subtracting 10t squared on both sides. Minus 10t squared. That will cancel the 10t squared on the right. 3t squared minus 10t squared will give us minus 7t squared. We'll write everything else down that we didn't cancel. We also want to get rid of the minus 30t. So we're going to add 30t on both sides. This will cancel the minus 30t. So we have minus 7t squared. We have minus 21t. If we add 30t to 15t, we get 45t plus 45t. Minus 45 equals 0. Now we can collect some like terms here. Minus 21t plus 45t will give us 24t. We've still got our minus 7t squared. We've still got our minus 45, and this will equal 0. Alright, we are finally at the point where we can use the quadratic formula. I need to write down that a is negative 7, b is 24, and c is negative 45. So let's write our formula down. Minus b plus or minus the square root of b squared minus 4ac, all of this over 2a. And this is what x usually equals, but we're talking about t this time, so we need to write down that t equals that instead of x. What does b equal? B is 24. So I'm going to replace the b with 24, remembering I've got a minus sign out the front there. Plus or minus square root. We now have b squared, so b is 24. We write down 24 squared minus 4. And we're going to multiply this by a and c. So a is negative 7. So we write negative 7 here. And c is negative 45. So we're going to write down negative 45 like so. Okay. We need our fraction. And at the bottom, our denominator, we have 2a. A is negative 7. So we write 2 times negative 7. Usually I write my three numbers with multiplication between them, but when you put numbers in brackets and put them next to each other, that just means that they're being multiplied. So the next step is to take our calculator and work out everything under the square root sign. We have 24 squared minus 4 times negative 7 and then times negative 45. So negative 45. What do we get? We get negative 684. So we're going to get negative 24 plus or minus negative 684. All of this over 2 times negative 7, which is negative 14. Now, some of you may have noticed that we have a negative number under the square root sign. What does that mean? What happens when I square root a negative number? Well, let's do that on the calculator. Let's square root negative 684. What do we get? Notice that we get an error. That's because you're not allowed to square root negative numbers. And this is one of those situations where rather than having 2 solutions or even 1 solution, we actually have no solutions. This happens whenever you get a negative number under the square root sign. So we don't have to express our solutions correct to 2 decimal places or as an exact solution. We simply write that there are no solutions. Now, before we conclude this video, I want to talk to you about one last thing. I'm going to make up a question, and it's going to be a quadratic. Let's have 3x squared minus 5x equals 0. What would you do if you were trying to use the quadratic formula to solve this quadratic equation? Now, I know that A is 3, and I know that B is negative 5, but what about C? I don't see a C here. What do we do in this situation? Well, C must be 0, because if we're adding 0, we actually don't put the 0 in there. So if you're ever using the quadratic formula and either the A, the B, or the C is missing, just use the number 0. Another example might be 3x squared plus 10. In this situation, we know A is 3, we know C is 10, but we don't know what B is. When you think about it, the reason for this is that there are no x's. And what does it mean for there to be no x's? Well, it simply means that there are 0 x's. So B would just be 0. Anyway, that concludes our video on example 3. Remember to read the description below for links to workbooklets that relate to this video.